Welcome back, ladies and gentlemen. We'll continue with lesson 4. And I worked all these out, so although it's a lot of slides, I'll try to move through it as quickly as possible. So I've already got the code written, so you can pause the screen to write the code. But and yours will not look the same as mine because mine's already worked out. So I'm doing that in the interest of expediency. Again, this is Cameron Say, North Carolina A&T. This is Python lesson 4, Introduction to Programming Using Python lesson 4. Okay, so what is it going to tell us? What is it asking us to do here? I'm reading from the instructions. Create a numeric variable, Brian, assign the value hello life to it. And so we've done that. And we'll run that. Well, it doesn't tell us to print anything, but we'll just run it to show that we have no errors. Okay, next. Here we're just assigning string values to a list of variables, Caesar, Praline, and Viking, the values that you see in the double quotes. And let's run this. I've already done it, so let's run this. Okay, that works fine. Next slide. So this is interesting. There's this thing called escaping characters. So this becomes a factor when you have strings. And for example, if you have a string that contains a quote or a double quote inside the string, you don't want the compiler to process that as a single or double quote. You just want it to print it out. So you do what's called escaping, and it's done different ways in different programming languages. In Python, the way you do it is you just put a backward slash before the character you want to escape. So in this case, the single quote. So we have, this isn't flying, and yours, I think yours, when you first come to it, I think it's like this. And if we ran that, we would get, we'd have a problem. So what we want to do is escape that character, backslash, and it runs fine now. We don't tell it to print out anything, but the instruction said fix the string editor. So we fixed the string editor, we ran the program, and we didn't get any errors. Next. So here is, and they don't call these arrays, but this is an array of characters. An array is simply a list, right? But an array is a very important data structure in programming. We'll talk about arrays later, but I want you to get a grasp of working with arrays. Now, arrays don't have to contain character values. They can contain string values. They can contain, well, they can contain string values too. You can have an array of strings. You can have an array of anything. They can contain strings, numbers, characters, etc. But the concept is always the same. And you have an indicator called an index that tells you what is the position of that element. And in this case, the elements are character values, the letters that make up the word Python. And so starting at 0, because we start counting on a computer, in most cases, there will be exceptions, but in most cases we start at 0 because the only two values in binary arithmetic are 0 and 1. Binary arithmetic is what the processor speaks, that's the language the processor speaks. So you have to start at 0. And every non-zero value is a power of 2. So the number 1, for example, the decimal number 1 is 2 raised to the negative power. I'm sorry, 2 raised. I've been recording videos all day. So 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, etc. So that's why we start counting at 0. And so here we have an array of characters. And what it asks us to do, it says we want to assign a variable 5th underscore letter equal to the 5th character, 5th letter, 5th element. Letter, character, element in this case are synonymous. In the string Monty, M-O-N-T-Y. And so the fourth value, right? The index of 4, but that's the fifth element. So you start counting at 0. 0, 1, 2, 3, 4. 4 is the fifth position, and we want to print that out. Run that. We print out the letter Y. Next, so here we're going to assign a variable parrot the value Norwegian blue. And now we're going to use, we're working on some string operators now. Length, or len, is the method. And the method is a pre-written set of code that does something. So in this case, the method, and sometimes I'll make the mistake of saying function when I mean method, but I usually don't say method when I mean function, but it's the same thing in procedural languages, non-object oriented languages. It is called a function. In object oriented language, it's called a method attached to an object. So, and this terminology will become clear to you as time goes on. But here we want to know what the length of this, basically what is the length of this string. So that's why we, that's the explanation for the syntax. And over here to the left, you see the others that we're going to use, lower, upper, and string. So we'll use those shortly. We're going to print out that. And, oh, I'm sorry, I skipped, I didn't run it. Yeah, so there are 14 characters in that string, including the space character. Space character is an actual character in ASCII, 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 the ASCII character set. I think the value of it is 20. And all ASCII character sets are in hex, but that's a whole nother discussion. But it is the space is a character. So we've output that. The length is 14. Now, what does it want us to do here? We're going to use the lower method to print everything in the variable parrot using lowercase. Oh, I keep skipping. I'm sorry, y'all. So yeah, Norwegian blue. You see it translates all those characters into lowercase. Next, we're going to use upper this time, same string, and we're just going to print that out. And I'm going fast through this because there's a lot of repetition, but you can slow this down. You can pause the video wherever you need to. Run that. We see it's all in uppercase. Next. Declare it and what does it tell us to do? Create a variable pi, which is a character. Which is a float. Float is a rational number, a number that is not a whole number. And we assign the value of pi. The first two characters to the right of the decimal point are 1, 4, and of course, if you know 8th grade math, it extends to infinity, or as far as we know. I don't think anybody's come to a finite calculation of pi. But interestingly enough, what we're going to do is we're going to convert that to a string, that number to a string. Now, understand that all numerical values can be represented internally in the machine as strings, right? And that's done quite often. To save space and to eliminate complexity and processing time, because it takes more time to process the numbers than it does to process the characters in terms of bytes. Anything I want to say about that? Oh yeah, so down the road we will see that in general, if you have a numeric value that you're never going to have to do any numerical calculation, like a phone number, for example. You don't add phone numbers. You don't add social security numbers. It makes perfect sense to do those as a string instead of a number. There are exceptions, but not many. Most cases, if you have a value ID number, right? You're never going to add ID numbers numerically. You're never going to perform arithmetic calculations on ID numbers or social security numbers or phone numbers. So those can be put in as strings. And we're converting pi to a string. Now it's going to print out the same characters, but understand that that 3.14 is now a string value, not a numerical value. Next. So yeah, this is dot notation, and what this is showing you is how to use the various methods in Python, and there are a bunch of them, to attach it to a variable. And the variable is actually an object, but that's an advanced discussion that we will have because Python is an object-oriented language. But the way you access the function, there I go again, the method, and use that the string value in ministry as the operator on that method is you just use dot notation. And so here you say it's ministry dot upper. And so when we run it, we see that it's all uppercase. And on line 3, we print the length of the string, which is 27 characters, including spaces. And on line 4, we print it using uppercase. 10. Next panel. So this is pretty simple. So now we're just printing out a string. Okay, printing out a string. Mighty Python. We run that, no problem. We've done that before. So in this panel, we're going to print variables. We printed a string, but we're going to print variables now that contain strings. So the first one is pretty simple. The instructions say declare a variable called the machine, the underscore machine underscore goes. And the reason for the underscores is that it's a token. Variable is a token, and it cannot contain blank spaces. So the underscore allows us to separate words in the token without having blank spaces. And we're going to print that. And it's pretty straightforward. We've done that before. So we're going to run this ping. Okay. Next. Now we're going to talk about string concatenation. Concatenation. And this is just tying together tokens, values of tokens. And in this case, the value, tying together the string values of variables. And when I say token and variable, I can use that interchangeably in this case. In all cases, the terms token and token and variables is not interchangeable. Some cases it's not, but in this case it is. I'll let you know when it's not. So we've got 3 strings here. Spam that we've output explicitly. We've written them out. Spam and eggs. And if you notice, I have a space before the closing double quote in spam and a space before the closing double quote in and. That's just for readability. We'll run that, and we see we have our spaces nicely formatted there. Right. So we just print out a list of strings. Next. Now, so here, and I'm gonna change this back to what it was on yours. So you see the error that I got. I think yours looks something like this. One thing you'll learn about me is that, my memory is not the best. And let me take a break here and say about when we're running these programs. So Python is an interpreted language. An interpreted language, you write it and then you just run it, right? You don't have to compile it. We'll talk about compiling in due time. And that's what makes interpreted languages a lot easier to use. That's what makes using Python easier to use than Java. When you have to make edits, you don't have to recompile it. You just make your changes and you run it. Okay. Now there's trade-offs to that. With simplicity comes, less precise, less precision, but the assumption is that you know what you're doing. So, and we're not doing anything terribly complicated, so we don't really need to compile. Let's run this. Should get an error. Okay, yeah, I do. Now, because it's trying to concatenate a string value and a float value. But if I run the string operator and make the argument, again, the argument is the explicit value for a method. And we'll learn about the difference between arguments and parameters shortly. And I run it again. It's nice. Now, because it's converted that 3.14 to a string value, has no problem doing that. Now, you can concatenate string values and numerical values, but we're not there yet. So let's go to the next one. We ran the code. We got the error, right? We got the error. And then we fixed it by converting that to a string, and we ran it. Okay, next. Making great progress. If you guys are sticking with these videos, I mean, you should be getting pretty comfortable with Python. And when you use it, you're in a very kind of sheltered environment here. But using Python on its own without this type of interface is not any more difficult. We will show you how to use it with tools like Eclipse and even with text editors. You can use, a lot of people code Python with just a text editor. And you have to have an interpreter running somewhere. Python interpreters are pretty easy to install, so you can install one. You can install a Python interpreter on your system and get it up and running and do all these exercises without this interface. So now, what is it saying here? So I really forget what it looked like, but whatever yours looks like, if there's an error, when you fix it, I forget what it is, but I don't want to change it because there's a little precision or complexity in the syntax here. So I'm just going to leave it as it is. But I'll explain to you what's going on. The %sign S indicator is that the first string that is in the program, right? So the first string is Camelot. That's the first string. Second string is place. And then this operator here lets you print multiple variable strings, or I should say multiple string values with using the variables. Instead of having to print out Camelot in place, you can just print out string 1 and string 2. So when the text is not long, you can the variable name is not much shorter, or in cases in one case it's actually shorter, but your strings can have you can quite often you bring in whole files of text as a string. So in this case, that would be somewhat cumbersome. And the reason you do that is because you want to perform some operations. For example, you want to pull out or identify all of the Johns in a file, or all certain zip codes in a file. That's somewhat advanced string processing. But let's run this and see what happens. So let's not go to Camelot. Let's not go to Camelot. See, let's not go to first string, to the silly second string place. Right. And let's go to the next one. Well, let's go back for a minute. So the reason they didn't print these out again is because we didn't tell it to. be intelligent. So yeah, should be able to figure out what's going on there. Now let's go to this one. Now this is good. I like this one. So here, if you look in the instructions, it tells you kind of what to do, right? And yours may have, I think yours has blank spaces here. But what it wants you to do is put string operators here, here, and here, right? And then it's going to print out the variable values here of name, quest, and color, right? So we're printing them out here. So raw underscore input is telling you, okay, I'm going to input whatever comes after raw input, whatever comes after raw input, I'm going to input that. I'm going to assign that value to the variable name, assign that value to the variable quest, assign that value to the variable color, right? But this is going to output. Now you'll see how it works momentarily. So I'm going to say cam knowledge. I don't have a favorite color, but so I'm make sure I'm recording. Yeah, I'm recording. So that's that. Now we hit enter, and it says it's going to do. So we've input cam, knowledge, and blue in these variables, name, quest, and color. Now it's going to come back and output these variables here, right? Where this operator, the string operator, is going to allow you to use multiple variable values. And so when I enter again, didn't work that time. Let me go back and do it. Let me do it better. Okay, so let's run this. Cam. Oh, got hung up for some reason. It's thinking. Okay. Go back. Okay, let's go next here. Okay, now it should work okay now. Cam. Oh, Okay, I messed it up. Let's run this one again. And then, okay, let's run this one. Hopefully it's gonna work this time. Down here is thinking for some reason. Well, anyway, it will work. You'll see what I didn't do. So you saw it input my name, and when you run it the last time, when you hit enter the last time, it's going to print this out. So your name is Cam, your quest is knowledge, your favorite color is, oh, maybe it'll work this time. Oh, no. So, got hung up. I'm doing, yeah, well, anyway, that's going to work. I don't want to hang in that. You'll get the idea. If you use this text here, it will work. I don't want to hold up the lesson because of that. I did something to the interpreter. And this is the last panel. Pretty simple. We create a variable myString. I wrote Python is fun. Print the length of it, of that string, and render that to upper. And we run that, and voila. That is lesson 4. We've learned something about the raw underscore input method and a lot about string processing. Okay.